Hello, everyone. So this is a look back at a question we dealt with in class, and I just thought it would be helpful to talk through some of the analysis that goes into this question. I'll show you two questions, and hopefully it will help you get a sense for the intuition behind what's going on here rather than just plugging in numbers and hoping that you're getting the right analysis out of it. So in this question, we learn about someone who's borrowing $200,000 for a mortgage, and we know what the mortgage payment will be. It's $1,073.64. Those mortgage payments occur every month for 30 years. And the question asks us for what the APR is, or the annualized version of the compounding interest rate. And so here's the calculation that I did, and let me just zoom in here for you. Here's the inputs. Well, stick over here on this side. And so we've got a present value of $200,000. That's the borrower's resources that they're receiving, the inflow of $200,000 for them. And then this outflow of $1,073.64 over 360 time periods. And we use that to that information, also recognizing that there's no lump sum amount at the end that either the borrower or the lender will make. And the relationship between this present value and these future values, the zero lump sum as well as the annuity of $1,073.64 every month, account for a relationship of a monthly compounding interest rate of 0.4167%. And an annualized version of that is at an APR of 5%. So that's just the rate times 12 to give us the 5% annual proportion. So let's look at the intuition of that using a graphic. Here's the intuition of having $200,000 today and the value of that $200,000 being paid off all the way down to zero in an even percentage rate to get us down to zero after 360 periods. So here's the bend of the curve. The question's really about what percent needs to be experienced to bend this line so that it gets to 360, given those amounts of monthly payments. So this makes it look like the interest rate of the 5% is the bend downward, and that's partially true, but it's not the full picture. Let's just focus in on the first year and what's really going on. Here is the increase that is the interest rate. So this is the 5% divided by 12, the effect on the dollar, and then here's the payment at the end of the first by the end of the first month. So here's the first month's growth, and then the payment that gets us down, and then another growth of interest and another payment, and another growth of interest and another payment. And the payment size, these vertical lines, will be fixed the whole way through the relationship of this loan. But the increase each month will get shallower and shallower. In fact, it'll get so that it's a very small increase. And so as we get further and closer to zero in 360 time periods, we're going to be really dropping. These will look more like steps than a saw. blade. So let's go back and look at that here in what it looks like in the flows. Here is the balance at the beginning when it comes in, the $200,000. And here's the interest that's recognized. This is the interest rate that's being used. So here we'll see I just took the balance outstanding and multiplied it by the interest rate that we had here, the 5% divided by 12, and then recognized the interest growth. So that's the balance before the payment. Here's the payment, and here's the balance after the payment. So what this $1,073.64 is telling us, what the calculation is the size of each payment. If it's a uniform, exactly the same payment every month, what size of a payment, given the size of a payment, how much interest needs to occur each period in order for those payments to reach zero after 360 time periods? So we could also, we could just change this payment, and let's say they pay $2,000. That's a lot larger, right? Well, now that is a much larger payment each month, and so the interest cost that will be needed to get this balance to zero at the end of the 30 years is going to need to be much higher, because it's absorbing a much larger interest. It has to absorb a much larger fixed payment to make this relationship between the 200,000 down to zero be true. Or we could take it the opposite way and say, what if we only made a payment? Well, 500 is actually negative amortization. Let's go negative 800. So if they pay $800 a month, that's a much smaller drop that the interest would cover in order to get to from 200,000 to zero. So this rate right here is not really trying to describe the bend of the curve in what and how much of a decrease this is, as much as it is trying to understand the size of the increase, the percentage of the increase that's necessary to cover this fixed amount of a drop each time period. You don't really have to fully appreciate that right now in order to be able to use the information, but that's the intuition going on here as to how we get from the $200,000 today down to zero at the end of 360 time periods, and with a 5% APR given this payment of $1,073.64. And just to show you that we do get down to zero, we'll scroll down here and you'll see that on this 360th payment, that $1,073.64 gets us right to zero. That's the future value we were wanting. Now let's look at the next question, which said, what would happen if somebody borrows $200,000 today and they make that same size of a payment over 30 years, but at the end they need to pay this additional $50,000? Now what is the interest rate? Well, recognize here that essentially what we're needing is an interest rate that will allow for enough growth so that the future value only accounting for this payment will be $50,000. So there'll be still $50,000 left in the principal at the end of 30 years, so that we then have to still pay for an additional $50,000 um, um, aside from after already paying all the monthly payments. So let's go back here to the inputs. So here's the graphic that accounts for this intuition of having this $200,000 initial present value that drops to the point where we still have $50,000 left to be paid off in the last time period. So this must mean that we have a higher interest rate so that there's enough growth going on between each time period to account for only reducing the balance to $50,000 by the end, rather than in the initial situation where we were paying it down all the way to zero. So let's look at that calculation. Here's the function where we have $200,000, and that $200,000 is in exchange for once again the $1,073.64 as an annuity, but there's also this $50,000 that needs to be paid at the end. So in order to accommodate that additional $50,000, when we get all the way to the end of the 360th time period, we have to have still a balance of $50,000 in there. And because of that, we need a higher interest rate so that our interest we have more interest growing, that this same $1,073.64 will not be able to pay it all the way off by the time we get to the end of the 360th time period, and rather, so you can see here we're down to the 360th time period, and that we had only paid off enough that we had one more $1,073.64 payment, and in addition to that, $50,000 that would be paid off. We'll pay both of those two items off, and we'll end up with a balance of zero. So another way to think about this is to think about these two future value streams, the lump sum and the annuity, as two separate obligations, but each one of them having a total present value of $200,000. Each one of them together having a present value of $200,000. So we could look down here at what my calculation is. Here's the present value of the annuity, which is $190,000 in change. And here's the present value of the balloon payment at the end, the $50,000. It's $9,792.98. The combination of these two together is the $200,000. So we looked at it with this chart, but we could also look at it this way, where here is what here's what the annuity is paying off, the $190,000 present value all the way down to zero. And here is what the lump sum is paying off, a growth that doesn't get reduced each time period, a growth that grows all the way to $50,000 in the 360th time period, and then gets paid off. So that's really the combination of these two flows, or these two present values, accounts for the 200,000. So this, when we first looked at it, the 200,000 was being fully covered by just an annuity, and now the 200,000 has two components to it: an annuity as well as the 50,000. But this 5.45 APR, it explains the relationship between 200,000 and these future flows, given given these two flows, we'll get to zero after the 360 time periods. Okay, I hope that is a helpful way of thinking through those calculations. At least it gives you a little more insight into what's going on, and gives you a better chance of wrapping your brain around this new way of thinking about financial transactions.